Okay, welcome friends. In this particular video, we are going to see the basic analysis of a epicyclic gear train. So, in epicyclic gear train, we need to understand what is the epicyclic gear train. A gear train having a relative motion of axis is called as a epicyclic gear train. Relative motion of axis. Okay, this is important term. Epicyclic gear train is also known as an planetary gear train. Okay. So consider this as a gear P and this as a gear S connected by an arm. Okay. In this, if this arm A is fixed, okay, if this arm A is fixed, the wheel S and P constitute a simple train. Simple gears will be there. Okay. However, if this gear S is fixed, so that the arm can rotate. Okay, this arm along with this gear P can rotate. Okay. So this will constitute a simple epicyclic train. Okay, and this wheel P will be called as epicyclic wheel. Okay. So this is what epicyclic train is. So before starting the analysis of a epicyclic gear train, we need to understand some basic concept. One of them is a velocity ratio. Okay, you need to understand what is velocity ratio. So you must have studied this. Velocity ratio is defined as the ratio of angular velocity of follower to the angular velocity of a driver. Okay, so if these are two gears, okay, having same mesh, gear 1, gear 2. Okay, so velocity ratio will be angular velocity follower to the angular velocity of driver. So consider this gear as a driver. Okay, some shaft is connected to wheel. Okay, and this wheel is rotating in clockwise direction. So this is driver and this is follower. Okay, so this gear will rotate in anti-clockwise direction. Okay, so one is driver, two is driver. So what is velocity ratio? The angular velocity of follower to the angular velocity of driver. Okay, so you must know what is omega and what is t, what is d, what is so omega is the angular velocity in radian per second, n is the angular velocity in rpm, d is the pitch diameter, and t is the number of teeth. Okay, sorry. So we have understood this angular velocity of the follower to the angular velocity of the driver. What is omega? Omega is 2 pi n upon 60. Okay, so if we give the ratio of omega 2 by omega 1, we will get 2 pi n 1 upon 2 pi n2 upon 60. Cancelling this thing, we get n1 upon we get n2 upon n1. This is 1. Okay, so by simply getting this formula, you can get how do we get this n2 by n1. Okay, from same you get this d1 by d2 and t1 by t2. Okay, so the formula for velocity ratio is omega 2 by omega 1 equals to n2 by n1 equals to d1 by d2 equals to t1 by t2. Directly proportional to rpm, inversely proportional to teeth and diameter. Okay, you remember this formula. Mainly these two are important. Okay, next, so we will start with the analysis. Okay, so consider these are two gears as simple. This is gear P and this is gear S and this is arm. Okay, so this is a simple epicyclic gear train. Simple epicyclic gear train. Okay, so let's start with the simple analysis. Okay, where is gear? Okay, I missed the gear. Okay, so this is in this way you have to form a table. So you have given two gears, we have given epicyclic gear train, and we have to find out the rpms or velocity of s. Okay, so first of all, in step 1, that is first law of table, assume a is fixed. Okay, assume a, what is a, arm a is fixed, so the revolutions of a will be 0. Okay, and turn this gear s through one revolution clockwise. Turn this gear s through revolution one clockwise. Okay, so revolution of s is 1. We have to find the revolutions of p. Okay, we have to find the revolutions of p. Okay, so how, in this case this s is a driver and p is follower. Okay, so velocity of p we have to find. Okay, this is what angular velocity ratio is equal to ts upon tp. Okay, this we get from velocity ratio, but here if s is rotating in a clockwise direction, we will be rotating in anti-clockwise direction. Okay, so considering clockwise as a positive and counterclockwise or anti-clockwise as a negative. Okay, ns upon np will be equal to minus ts upon tp. So what we are trying to do here, we are trying to get the equations that can solve this problem. Okay, so we are getting some equations. Using those equations we will get the final solution. Okay, so first step you have understood. Now turning on to second step. Okay, in second step also consider this as a gear, same gear. Okay, this is p, this is s, this is arm a. Okay, turn s through x revolutions. Okay, you have understood the first. Now second, suppose a is fixed and turn s through s plus x revolutions. What is s? S is 1, so x revolution. Turn s through x revolution. Okay, turn s through s. Okay, arm a is fixed, this becomes 0. Turn s through x revolutions. Okay, so revolution made by s will be equal to x. So what will be the revolutions made by p? And p will be ts upon tp. It was earlier ts upon tp into x. So okay, the revolutions made by p will be minus ts upon tp into x. This is your equation. Okay, you get second equation. Okay, turning on to next. If a mechanism, okay, now we have to get a third equation. Consider, okay, first stage is complete, second one, now we are going to third stage. Now what we have to do at third stage, simply add y to all the equations you have obtained earlier. Okay, simply add y to all the equations you have obtained earlier. Okay, so if a mechanism, how we will get this? If a mechanism, consider if a mechanism is locked together and turned through a number of revolutions, let the lock system be turned through y revolution. Okay, this whole system will be turned through y revolutions. Okay, the revolutions made by a will be y. What will be revolutions made by s? Y plus x. And what will be revolutions made by y? Made by p? Y minus ts upon tp into x. This is your final total motion you have to obtain. Okay, so here this is a basic simple gear train. Okay, if there are more gears, you add a more column, obtain the velocity ratio of that gear. Okay, that will be simple. Okay, so this is the procedure through which you can obtain the basic analysis of a simple epicyclic gear train. Okay, let's take a simple example of same gear, same arrangement. Okay, so what they have given, an epicyclic gear train consists of an arm and two gears A and B. Okay, two gears, gear 1 A and gear 2 B, and arm. Okay, gear A having 30 teeth and gear B having TB equals to 40. This is TA equals to 30. Okay, the arm rotates about the center of a gear A at a speed of 80 rpm counterclockwise. Arm A 80 rpm counterclockwise. Determine the speed of the gear B. Same what we have carried out. We are learning this example so that we can remember the whole procedure. And let's see the total application of the same. So how will you determine the speed of gear B in two conditions? One condition when arm A is fixed, and second condition when the gear A revolves at a 240 rpm clockwise. Okay, remember this. So let's start the solution. What you have to do? You have to directly build a table. You have to directly build this table. Okay, and then this diagram, and we will start with our solution. Okay, make this sphere. Okay, simple table, simple gear. Okay, this is just here instead of S we have this is A, this is B. Okay, instead of S we have here A and we have here B. Okay, we will do that. We will do that. Okay, TA upon TB. TA upon TB. Okay. See this simple modification you have to do. Okay. So what is given? TA equals to 30. TB equals to 40. Okay. And arm A rotates at 80 rpm counterclockwise. Okay, this is given. Okay, let's start with the solution. Okay, what is first given? Okay, let's start first. Arm A is fixed. Sorry, gear A is fixed. So if gear A is fixed, what is the revolution say equal to 0? What do you have revolutions of A? Revolution of A is x plus y. X plus y will be equal to 0. This is first equation. And what is other condition? What will be the revolutions of P? Okay, gear A is fixed, x plus y equal to 0. And arm, revolutions of arm A will be y equals to minus 80. Counterclockwise is negative. So x minus 80 equals to 0. X equals to 80. Okay, if x equals to 80, will you able to get this? What is revolutions of B? That is NB equals to y minus TA upon TB into x. What is y? Y is your minus 80. Minus TA upon TB. What is TA? 3 by 4. 30 upon 40 into x. What is x? 80. Cancel this. 420. Minus 80 minus 60 equals to minus 240 equals to revolutions of B will be 240 rpm counterclockwise. What is this minus? Counterclockwise. Simple, very simple, just basic mathematics. Okay, condition 2. What is condition? What is second condition? A revolves at 240 rpm clockwise. A equals to 240 rpm sorry, this mistake. This is minus 80 plus minus 60 minus 140. Okay, so A revolves at 240 rpm clockwise. Yes, this is positive. A equals to 240. What is the revolution of A? x plus y. What is revolution of A? Is x plus y. X plus y equals to 40 to 40. And what is y? Revolutions of y is minus 80. Y is equal to minus 80. Simple. So x minus 80 will be 240. So x will be equal to 240 plus 80, 320. Okay. X will be equals to 320. Okay. So what will be next step? Next step will be this that nb equals to y minus ta upon tb into x. What is y? Minus 80. What is ta upon tb? 30 upon 40 into x is 320. Okay, cancel. 80. 8 3s are 24. Minus 80 minus 240 equals to minus 320. What this minus indicates? 320. What this minus indicates? 320 rpm. Oh, 320 rpm counterclockwise. As simple. Thank you.